Assalamu alaikum, everyone, and a very good evening. I believe we should start now. We have a handful of participants. Welcome to today's webinar, which is titled Careers in Quantum Computing. My name is Imran Bhamani. I'm a volunteer with Aga Khan Education Board for Pakistan. And we've restarted these webinars which will guide you on different topics. So today's topic, as I told you, is careers in computing. Before we start, I just want to tell you that please, because we've restarted now and we want many people to join these kinds of webinars. So share this email, share the posted videos with your friends and family. We also have a newsletter on career.substack.com, which you or your friends and family can subscribe to. We have a YouTube channel on which we will also be going live today. So this Zoom session will also be live broadcasted on our YouTube channel. So yeah, let's start now. I will quickly introduce we have Amin Gilani, who is going to be our expert today on this topic. He is a PhD student in the Department of Computer Science at the University of Maryland, College Park. He's specializing in quantum information, and he's already completed his master's from the same department on a Fulbright scholarship in spring 2022. Just a quick house rules. We'll have the formal Q&A session at the end of the session. But if there are any queries in the middle of the session, please post it on the chat window, and we will get to them at the end of the conversation. And all your comments or queries will directly come to the host, and we will share it accordingly at the end of the session. So thank you very much. Amin, over to you to start with the formal presentation.
Thank you, Imran. And yeah, maybe let's get started. So as you're aware, the topic of today's webinar is careers in quantum computing. And before we talk about anything else, let's first start with what is quantum computing. So maybe I'll describe, like, because quantum computing only has a theoretical aspect, like at this point, it's broadening itself, and it's going to be very practical very soon. But we'll start with, like, what is quantum computing as it's understood these days. So as you're all aware, mathematics is about problem solving and like solving mathematical problems, and there's a subfield of mathematics in computer science which is called theoretical computer science. So that subfield is also about solving problems, but now we also care about, like, how much time we are going to spend in solving those problems. So we want to find efficient solutions to those problems. So we want to find algorithms. We want to find procedures which run very fast in the real world, and that's what theoretical computer science is about. And quantum computing is a subfield of theoretical computer science. So it is about solving problems efficiently, but now you're allowed to use the principles of quantum mechanics. So what does this mean? So electrons at a very micro level do perform very interesting computations, in which and they can be they do, like, some sort of weird stuff. They can be in the ground state or in the excited state at the same time, which is not like intuitively very which is not very intuitive. And then you might wonder that like, is that even helpful to be to be sort of like have that sort of like a parallel picture of the world where you can do maybe two things at the same time. So so people thought about it, and then people thought that maybe we take those principles and maybe we apply those at the macro level and see what we can do, like what we can do with solving problems. And it turns out that quantum computing, or the principles of quantum mechanics, when you make a model of computation out of those principles, you can actually perform some tasks faster with quantum computers that you might not be able to do it with our home classical computers. So now the question is that how fast can we do it? That's like the central question of quantum computing. I'm not going to answer that. I'm not going to go. I'm not going to take a deep dive into it, but maybe we can talk a little bit about the applications of quantum computing. So it is well known for a while now that if we are given an unordered search, an unordered database, so we're given like tons of information, and we know that it doesn't have any order, and we want to search for a useful information in that database of information. And classically, you might think that if you want to do that search, we will just look at each item and we'll see that if it's useful for us, and if it's not, we are going to discard it, and we are going to one by one look through all the items in the database, and we are going to see that if they're useful or not. So for searching for a database of size 1 million, you might need 1 billion steps, but with quantum computers you can do it quadratically fast. So which means that for example, if you have like 1 million pieces of information, and if you want to search for a relevant piece of information out of that database, you would just need 1,000 times steps of a computer. So which makes many problems which are not practical in the real world if we are going to use quantum computation. And there is also there are also like much better speedups that you can achieve with quantum computers. So for instance, you can solve a certain mathematical problem, which is called factoring, exponentially faster with a quantum computer. So what does that mean? What's the implication of that? So many bank systems rely on the notion that the problem of factoring is hard. So which means that if you give like any person like any number of classical computational resources, that person will not be able to factor integers in efficient amount of time. But now we have a fast quantum algorithm for factoring. So which means that quantum computers can actually break those bank systems. So is this a negative application? I would say no, because that power of quantum computing highlights that there is something in nature which is highlighting some weakness in our current bank systems, because our bank systems are making some assumption which is probably not true because of some powerful natural phenomena. So but the good thing about this is that even though quantum computing can break the current bank systems, it also allows for the construction of systems which are also secure from quantum attacks. So so these days this field is called post-quantum cryptography, which is about doing communication in a world where even the malicious parties have access to quantum computers. And now what we can do? Can you still do secure communication? And the answer is yes. There are many protocols that allows you to do it, and the field is still evolving, and there's a lot of work being going on there. So here I motivated quantum computing from computer science and from mathematics, but many people would argue that quantum computing is more of a subfield of quantum information science, and so we might also want to understand like what is quantum information science? What does it involve? So it's about there are many things that you might. So here is a chart on the left side which involves like a lot of things in quantum information science. So for instance, like it involves ideas in like communication. So for instance, like if there are two people who would like to communicate, but they're afraid that if they're going to send messages over a channel which is public, they somebody could intercept those messages and may get some information which they do not want to share with the with somebody else. So um, so so how can you use the power of would like to work with people who are highly whose research interests are highly correlated with their research interests, and if you're and another piece of advice is that before applying for your master's or for your PhD, you might want to do some research in your area, so that so that that shows some evidence to the admission committee that you're highly interested in doing research, and you can actually accomplish research. And yeah, um, so maybe let's move forward and let's talk about opportunities. So what are the opportunities in this particular area in quantum computing or in quantum information science in general? So until recently, most of the opportunities have been in academia. It is because quantum computers have not proven to be practical as of yet. Like we don't have like practical quantum computers. We have like we have made like we as the so we have made some recent advancements in making like small scale quantum computers, but still like it's a very evolving field, and it's going to develop a lot. So most of the opportunities these days are in academia, or in research, or in teaching, or but now I would like to say that things are changing exponentially fastly. Things that there are already some small qubit quantum devices. So for instance, IBM has built like 100 qubit quantum computer, and it has given open access to all those who are its premium members or something like that. And so which means that there are careers these days now for engineers or for experimental physicists who would like to actually work in building those quantum computers. And maybe like once we have like full-fledged quantum computers for daily use, there will be careers which I think will be probably very soon. There will be careers for software engineers, and that's and another reason for that indication is that there is a recent advent of quantum programming languages. So we have like theoretical guarantees, we have theoretical algorithms that run faster than classical algorithms. But now these days, these algorithms are actually being programmed in quantum programming languages, and they are to really see that like how much advantage or how much how fast they are in the real world. And so there have been quite a bit of progress in that area, and I guess there are going to be many careers in that direction as well. And that's the end of my presentation. So thank you for listening, and I would like to if there are any questions, I'd like to answer them.
Thank you. Thank you very much. I think we did receive a few questions, so I'll just ask you those right now. So can you tell us, can you tell us what are some practical fields where quantum computing can be applied?
So of course, so maybe one practical application would be medicine. I would say it's a very important application. And for instance, like I do not understand medicine too much, but what I think happens is that, like, when you are coming up with medicines, you are trying to construct antibodies of the diseases so that, like, those fit together and then your disease is cured. But then in order to search for those antibodies, you have, like, lots of like lots of possible uh, constructions of those antibodies. And so, which means that you have to search through, like, all those antibodies, but you cannot do that classically because it takes really long time, and that it might take like more than the lifetime of the universe. So that's why probably cancer is not cured. But maybe if you could do it like with a quadratically faster machine, probably with a quantum computer, you can maybe find like some cures of some forms of cancers, maybe like in a very efficient time, and that could be like really, really important. Another application would be in machine learning and in AI. So yeah, again, I do not know too much about these fields, um, but AI also requires like searching through like databases of like huge sizes, and with quantum computers you can do that fast. So that's really important again.
Hmm. So you told us that at least so for sure there is a degree required to become a, to get a job. Is it like a mandatory requirement if you want to get a job? There's a degree required for computing?
Well, these days you require a degree for pretty much everything, because the market is so competitive. So I think I think it's going to change pretty soon. If probably if you would have done your bachelor's in computer science, you can easily get a job in software engineering or something. But because quantum, there are not like many jobs in quantum computing because we don't have like full-fledged quantum computers. But once we get there, I'm pretty sure that you would not need to go beyond like bachelor's in order to get like a pretty good job. But these days, I guess we are not there already. So I guess like most jobs are in, as I talked about, most jobs are in academia, and that require you to do like, a graduate degree.
Okay, so basically we're talking about more and more research related jobs when it comes to quantum computing, right?
Yeah, but it's changing pretty soon, so I'm hopeful for other jobs.
Are there many universities offering courses in or degrees in quantum computing, or are there any few?
So at the undergrad level, I don't think there are any universities which offer like a degree in quantum computing. They might offer a specialization or might offer like a couple courses, but maybe like most universities offer like at most one course in quantum computing. But if you take that course and if you're interested, there are many master's programs and many PhD programs which allow you to specialize in quantum computing. So because PhD programs are more about your research interest and your supervisor's research interest, and the market for like academics is pretty intense. It's pretty good these days. So there are many like many good researchers who have done like pretty good research in quantum computing, and they're looking for students. So there are many opportunities for PhD students.
Okay, one last question. Do you need to learn programming languages in order to pursue this career?
Well, it doesn't hurt to learn anything, but especially like if you're interested in quantum programming languages, then sure you would need to have some knowledge of programming languages so that you can easily translate it to when you're trying to learn quantum programming languages. But specifically if you want to like have a theoretical career or a research career in quantum computing, it's totally fine to have like a basic understanding of programming. Or if you're being a quantum physicist, it's totally fine to not really know programming.
Right. And let's say if somebody, acquires this qualification and then realizes that, quantum computing is not for him, then what else can be done with this degree?
Well, so I mean,
how do you make it a reusable skill, in other fields which are more related?
So I guess as I talked about earlier, many fields in within quantum, there are many fields which are highly connected. And so if you know quite a lot about quantum computing or maybe quantum physics or quantum chemistry, which means that you know a lot about physics or chemistry or computer science. So you can like switch back out if you feel that this is not for you, and you can so I guess at the undergrad level there are not like any degrees for quantum computing, so there's so any degree that you'll do will be like broad enough for you to make any choices in your career that you'd like at like after you have finished your degree. And if you're doing like a graduate degree, then I think that you might be pretty interested in the research that you'd like to do if you're pursuing a graduate degree. And like after pursuing a graduate degree, if you're still not interested, then probably you have done like enough for you to for you to shift to maybe some other relevant fields.
So you think that if somebody comes back to Pakistan after doing this degree, if not now, maybe a few years from now, maybe 5 years from now, what do you think that, at that time, what will the value of that degree, or, what new fields will be available to pursue it?
So in the worst case, you can definitely become like a professor or a researcher, but if you want to talk about like the real market or like the industry, maybe one thing would be to be like if you know a lot about like quantum devices, then you can be surely like an entrepreneur and like like come up with your own idea of how because this is like a game-changing idea, and maybe like there is like some industry already like in the United States, and I'm pretty sure like the world is going to follow. So yeah, so if you know a lot about like quantum sciences, then you can come up with startup ideas that could really connect your knowledge with the real world, and maybe you can get a pretty good career out of it.
So thank you very much. I think it was a very good session. Thank you very much for sharing your thoughts and your presentation on careers in quantum computing. We got some interesting questions and interesting queries, and I think for the participant side, thank you very, very much. Again, to all the participants, you can even send us questions later on the career.substack.com, which is our page for the newsletter. And this video was live broadcasted on YouTube as well. So on YouTube, if you have comments later as well, you can post any questions there. So don't forget to ask your friends to subscribe to the newsletter on the Substack and our YouTube channel, which is very, very important. And we will be continuing this series of webinars, we'll be bringing more interesting, career advice for you, and in different fields, upcoming fields in technology and other fields. Your feedback is again very, very important. So do please keep on sending your advice or your comments, your feedback to our official page, and we will try to take that into account and send you with arrange more seminars and more webinars like this. So thank you very, very much, everybody, and a very, very good evening to you guys.